Hello and welcome to Guessing the Methods exam. This is part 7. This is the last tech-free one and we're going to see some interesting questions here written by my friends. Check them out at their tutoring company. They do great stuff. Sign up, join up, do what you got to do. Let's get started. Alright, this is a warm-up question. Alright, binomial probability. You're supposed to just know this formula. We're going to flip a coin 9 times, and we've got 5 successes. So, what's the formula? Well, all these formulas look the same. 9 choose 5 is obviously the correct idea, right? 5 successes from 9. The next part of our formula should be the number of successes, 0.5. Okay, to the power of the number of successes you would like to have. So I would like to have 5 successes. The next part here is, this whole bracket is the probability of failure, right? So it's 1 minus the probability of success, 0.5, which just happens to also to be 0.5. And then here, it's going to be the number of failures, which you can find by saying, all right, well, here are my successes. It's going to be the total number of trials minus the number of successes. 0.5 to the 5, 1 minus 0.5, 9 minus 5. I've got an answer. The answer is D. Super warm-up question because the short responses, they're going to get wild. But a question like this is important to have in your toolkit. They do these in tech-free exams because they can't have you sort of calculate it, so they get you instead to just identify which formula would work. All right, we're going to do a celebration and then we're going to get started. Have a read. Have a try, then we're going to do it. Alright, so this is a classic of the sine and cosine rule genre, right? It's like a 3-dimensional deal. So, if you're not familiar with drawing in 3 dimensions, let's have a try at it. I'm going to go this way, this way, this way, right? So this is like out of the page, this is across, and this is up into the sky. So this bit here, like we're talking about north, south, east, and west. North on my drawing actually is parallel to that, which means that this arrow is facing south. Hopefully we understand how that works. Drawing in 3 dimensions can be tricky. Okay, we have a tree, and this is going to be my tree. That's my tree. Okay, and we have a person, Maddie, who is standing directly south of the tree because it says Maddie is looking at the tree and the tree is directly north of Maddie. So here is Maddie, right here. M for Maddie. Now, it also says there is an angle of elevation from Maddie to the top of the tree. And that angle of elevation, right, so she's looking up at the tree, 60 degrees. Okay, what else have we got? Davina, is that her name? Alvina walks away from Maddie at a bearing of 285 degrees true. Okay, so this is north, 285 degrees true. So that's 270, right? Because if you go all the way around, 270, another 15 degrees makes 285. So 285 is like in that direction. And then it says until she can make a 60-degree angle with her arms, so that one arm's pointing to the tree and the other arm is pointing to Maddie. All right, so like a dotted line there. So that's Alvina, and there's a 60-degree angle between the tree and Maddie. 60-degree angle there. And I guess she can also look up at the tree as well if we wanted to. Okay, what else have we got? Any more information? 50 meters. Well, it is known that the distance between Alvina and Maddie is 50 meters. Alright, so we've got a little bit going on here. It is at this stage that I would like to remind you that this is a tech-free exam. No calculators. Okay. Something I didn't draw on here was the fact that the angle around there, or all the way to there, is 285 degrees. So if that angle from there all the way around to there is 285 degrees, then the angle inside the triangle itself, so between here and here, like that, that angle is 360 minus 285, which is 75 degrees. That's important information, right? And so I don't know how to do this question. We just got to step through it. If this is 75 degrees and that's 60 degrees, those two together are 135 degrees, which means that this angle here, right? So if you're standing at the tree and you're pointing at Alvina and pointing at Maddie, that angle there is 180 minus 135. So that angle there is 45 degrees. All right, so I'm just going to draw one more picture. I'm going to come over here and just do like a top-down view of just the triangle here with Alvina, Maddie, and the base of the tree. All right, so I know that's 75 degrees. I know this is 60 degrees. I know this is 45 degrees. And I know this is 50 meters. Okay, what length could I find? I think I can find the length between Maddie and the tree, right? Now, I'm going to avoid this length here. This length here looks problematic because there's a 75-degree angle there, and I don't have a calculator. I don't know how to deal with 75-degree angles without a calculator. But this 60-degree angle and this 45-degree angle, I like those. All right, so I think it might be a sine rule question because I see a length of 50 over sine 45 equals, I don't want to find that, I want to find this, equals x over sine 60. All right. Now, we know what sine 45 is, so 50 over, depends on how you want to write it, but I'll write it as root 2 on 2. And we know sine 60, let me think about that one, 1, 2, root 3. Sine of 60 degrees is equal to opposite over hypotenuse, root 3 over 2. Okay, so this is weird because it's like nested fractions, fractions on top of fractions. 50 divided by that fraction is the same as 50 multiplied by the reciprocal of that fraction. So it's the same as 50 times 2 over root 2. And then if I multiply both sides by root 3 on 2, that means that we get rid of that horrible root 3 on 2 from this side. And so now we know that x is equal to 100 times root 3 over root 2 times 2. In fact, we can get rid of our 2's here, and it's just going to be 50 root 3 over root 2. So what have I done? I've found this length here, from Maddie to the tree, I know is 50 root 3 divided by root 2. Okay, I'm just going to move this out of the way and just keep this value. So now that I've got that length, I'm going to, from my picture here, I'm going to draw another triangle. I'm going to point in that direction, and I'm going to draw this triangle here. So that's the base of the tree now. That's Maddie, and this is the top of the tree. All right, so we've been told that this angle is 60 degrees. That's our angle of elevation. There's a 90-degree angle there. I just calculated 50 root 3 over root 2. That's the length. That's the length from Maddie to the base of the tree. And the question we're being asked is, what is the height of the tree? So we can use some trigonometry here. We can say that tan 60 is equal to opposite over adjacent is equal to the height of the tree, let's call it h, over 50 root 3 over root 2. Now I think I know what tan 60 is, there's 60 degrees. 1, 2, root 3. Tan 60 is equal to opposite over root adjacent. It's equal to root 3. So root 3 is equal to h over 50 root 3 over root 2. Alright, now I can multiply both sides by 50 root 3 over root 2. Root 3, just make a bit more space, times 50 root 3 over root 2 is equal to h. Alright, so h is equal to root 3 times root 3 is 3. 3 times 50 is 150. 150 over root 2. I am finished. This is my answer. Some of you might be looking at the screen and thinking you've got to like rationalize a denominator or something like that. Not in the syllabus, not required. I think 150 over root 2 is a fantastic answer. Should I put units on it? Yeah, absolutely. Meters. But I am done. I am celebrating. And next question. Alright, this is a question. Have a try at it, see how you go. Now I like this one because it's a kind of puzzle, I guess. We're told this function here, it's got j's, k's and l's as unknowns. And then we're given a bunch of information about it, and we go from there. Alright, so it's not as if, I'm going to do it, and I'm going to show you like, here's step 1, here's step 2, here's step 3. This is not how someone would do this kind of question in the wild. You've just got to look at it, write down some information, and then think about what to do next. And the order in which I do it, not necessarily the order I would do it in an exam. Maybe I'd change up the order, but don't be under the impression that complex unfamiliar questions, like I'm some sort of person that can just see this is the first thing that must be done. Okay. Now, it does say the only vertical asymptote for the function occurs at x equals 2. Okay, so asymptote at x equals 2. Now, what are asymptotes? Asymptotes are values that x cannot be. Asymptotes are values that x isn't allowed to be. So an example of that is f of x equals 1 on x. This function looks like this. It has an asymptote at x equals 0. And the reason for that is you're not allowed to divide by 0. So that's what asymptotes are. They're things that x isn't allowed to be. And in this case, in this function, x is not allowed to be equal to 2. So what constraint do we have here? Well, we've got log something, something, right? And there's a rule with logs. Just like you can't divide by 0, like that, you also can't take the log of 0. So that means that all of this stuff, k bracket 2kx minus kl over 2, and then squared. Now, when that is equal to 0, that's when we'll have our asymptote. Asymptote at x equals 2, when this is equal to 0. That's when the asymptote will happen. So we can sub in x equals 2 in here. So k bracket 2 times 2, so 4k, minus kl on 2 squared equals 0. And now we've got a null factor law thing happening. K must be equal to 0, right? Because it's this times this makes 0. Or 4k minus kl on 2 squared must be equal to 0. Now, we can reject one of these. K can't be equal to 0 because it says 3 positive non-zero constants. So k is not 0. So let's continue on down this path. If I take the square root of both sides, I get 4k minus kl on 2 equals 0. Okay, now I can just kind of do a little bit of something like that. 4k equals kl on 2. Multiply both sides by 2, I'll have 8k equals kl. And then I can divide both sides by k. L, that's L. L equals 8. Okay, that is 1/3 of the way there. And let's sort of recap what we figured out. We were told a certain thing. We were told the only vertical asymptote occurs when x equals 2. We know that asymptotes happen when x is not allowed to be. And this is not allowed to be. This is not allowed to happen. And so when x equals 2, this occurs. And so then we work through, and magically everything cancels out except for our l's. L is equal to 8. It's at this stage that what I would probably do next is rewrite this with L being equal to 8. Alright, so I've rewritten it with L being equal to 8, and it just so happens when you put 8 in here, 8k divided by 2, you get 4k. And so that's my 4k here. Now, what else have we got? It has a singular y-intercept at y equals -1, and an x-intercept at x equals -2. Alright, that feels useful, right? Because we know when y-intercepts happen. Y-intercepts happen when x equals 0. And x-intercepts happen when y equals 0. So I've written those key pieces of information here. So this says when x equals 0, y equals -1. That's my y-intercept. And it says when y equals 0, x equals -2. That's my x-intercept. What I'm going to do is sub this into there and sub this into there and just figure out which one feels like it might lead somewhere. So I have -1 equals log j blah blah. That's a 0. So that bit just becomes -4k. And then this bit, -4k squared, becomes 16k squared. And 16k squared times k is 16k cubed. Looks good, looks simpler, but I don't see an easy way to deal with the j and the k in this. I'm going to abandon ship. I'm going to go over there. Okay, I've let y equals 0. I need to sub x equals -2 into there, which is going to make that -4k, which is then going to take this -4k and make it -8k. But then when I take that and square it, I get 64k squared. And then when I take 64k squared and multiply it by k, I get 64k cubed. And it's at this stage you might look at this and look at this and think, hey, maybe simultaneous equations. There's a j and a k, there's a j and a k. And maybe you can, I don't know. But there is something else I notice. This says 0 equals log j 64k cubed. Log of something equal to 0. That means the something must be equal to 1. That's one of your log laws. Log base e, log base anything 1 is always equal to 0. Which means that for this to be true, I actually don't care what j is at all. If it's equal to 0, the only way that can be true is if 64k cubed is equal to 1. Therefore, 64k cubed is equal to 1. That means that k cubed is equal to 1 on 64, which means that k is equal to the cube root of 1 on 64. And then that's just asking, well, what is the cube root of 64? Something times something times something makes 64. That's 4. And something times something times something makes 1. What is that? 1. I've got a k value. K equals 1/4. So now I know that L equals 8 and I know that k equals 1/4. I can now go back to here. Because if I know what k is, I can sub it right in there. Okay, so I've done that. This 16 times 1/4 to the power of 3. Oh, I already know what that is. That's 1 on 64. So log j, I get 16 over 64. 16 over 64, that's 1/4. Alright. And it feels like I'm kind of stuck at this point. But maybe not. Maybe I can write this in exponential form. So maybe I could say that j to the -1 equals 1 on 4. J to the -1 is just 1 on j. So that means that j is equal to 4. 1 on j equals 1 on 4. That means that j is equal to 4. I think our job's done. It just says write the equation for h of x. we can now say that h of x is equal to log base j, which is 4, and then finishing it off, k 1/4 2 times 1/4 x minus 1/4 L, which is 8 on 2, and then that squared, and then close that up. Now, obviously, there's more work we can do here. We've got a quarter there. We've got 2 times a quarter, which is 1/2. So we can make that 1/2. I've got here a quarter times 8, which is 2. 2 over 2 is 1, so I can call this 1. I think that is a pretty good equation. I like this question, a very clever question, really relies on your ability to spot those log laws and then be able to sort of work through it. I also kind of like you just got to puzzle through this one. I like it. Last one. Here we go, last question, and it's a doozy. Have a try. Okay, so there is a lot going on here. Trapezoidal rule, and there's this new formula we've been given. So whenever they do this, whenever they give you a new formula in an exam, you've got to use it somehow. Okay, let's start by understanding the question. Now, we've got some sort of function, just draw in a rough sort of sketch of it, because we know half of x squared. You should know what half of x squared is. It looks like that. It's a quadratic, right? We're going from 0 to 5, and we're estimating the area under the curve by using an unknown number of strips. Could be 5, could be 20, could be 100. Who knows how many strips we used, but when we used that exact number of strips, we got that exact answer. All right, let's write down the trapezoidal rule formula. So here's the formula that I'm going to be using. The area is equal to, or at least approximately equal to, the width of each strip divided by 2, all multiplied by f of 0, the first strip, f of 5, the last strip, then those middles there. We've got a big problem here because we don't know how many middles there are. There could be 100 strips, could be 1,000, who knows. Let's start subbing in what we know. We know what the area is going to be. It's going to be 335 over 16. All right. What about this W? What's that? That's the width of each strip, right? And the thing that we don't know N. We don't know how many times it's been cut up. But we know that the width of each strip would be equal to the number 5 divided by N, divided by the number of strips. So W is equal to 5 over N. So W over 2 is equal to 5 divided by N divided by 2. So W over 2 is equal to 5 over 2 N. Now f of 0, if you sub 0 into this equation, you're going to get a big 0. Now I don't know about these middles, let's just write them as 2m for short. But f of 5, I know what happens when I sub 5 into my equation. Half of 5 squared, 25 over 2. Alright, now the middles, I'm so scared of them, right? They're so horrible looking that I think I'm just going to avoid them for a little while. What I could do is divide both sides by 5 over 2n, right? So I just do a little bit of scrap working here, 335 over 16. If I divide that by 5 over 2n, that's the same as multiplying by 2n over 5. The 2 and the 16 can cancel out to just become like an 8 on the bottom here. 335 divided by 5 is like 67. So 67 over 67n, there's an n there, over 8. Alright, so my left-hand side is going to be 67n over 8. That gets rid of this 5 on 2n on this side. This 0 here is just 0. I've still got this 2m going on, and I've still got this plus 25 on 2. I can probably get rid of the 25 on 2 by subtracting 25 on 2 from both sides. Now that's 67n over 8 minus 25 over 2. 25 over 2 is the same as 100 over 8. So I can just make that a single thing. And finally, I can get rid of this 2 by just dividing by 2. All right, so what does this say? If I do all of my middles, right, the sum of my middles and sub them into this equation, boom, 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 it's going to be equal to 67n, the number of strips, minus 100 over 16. I really need to deal with the sum of the middles. The time has come to start figuring out how to deal with this sum of middles. All right, so let's deal with sum of middles. Sum of middles. All right, so what I need to do is, here's my first strip, however wide it is, I don't know, right? But I need to sub in the x value of my first strip. Now, the x value of my first strip is just going to be like w. So, half, because that's my function, half w squared. That's my first strip. My next strip is half w plus w, 2w squared. That's my next strip, right? I'm finding the y coordinates of each strip. Plus half of 3w plus half of 4w. All right, and you can see where we're going here. Now the question is, like, how does this end? How do we, because we don't know how many w's there are. There could be 100, there could be 1,000. Well, we're saying that there's going to be n strips, right? So if there's n strips, this last one here is going to be n minus 1. Because this was my first w, right, here. And if I keep going on, I'm not going to get to the n, because that's here. I'm going to get to n minus 1. Plus half of n minus 1 times w, and then square that. All right, beautiful. Now, I've put this little dot, dot, dot in here. That's customary. You don't know how many are in the middle, right? We're just going w, 2w, 3w, da, 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 and then n minus 1w. That's our last number. Now, what did we say earlier about w? W isn't w. W is like 5 on n. So we can write each of these w's not as w, but instead we can write each of those w's as 5 on n. Why would I want to do that? Well, because there's an n in my formula and there's a w in my formula. I don't like having 2 different variables in my formula. It'd be better if I just had 1 in my formula. All right, so half of 5 on n squared plus half of 2 times 5 on n squared plus half of 3 times 5 on n squared, etc., etc., etc. Now, there's actually some cool factorizing that we can do here. All right, remember what we're doing. This is the sum of the middles. This is the sum of the middles. All right, so notice that there's a half. Everything's got a half out the front. So I can actually, like, say m is equal to 1/2. And, like, bring that half out the front. Just like that. What else can I do? Well, hang on. 5 on n squared. What is 5 on n squared? That's 25 on n squared. Look here. 2 times 25 on n squared. 3 times 25 on n squared. 4, 5. There is a common factor all the way through here of 25 on n squared. So not only can I bring out the common factor of 1/2, I can also bring out the common factor of 25 on n squared. So now that I've brought out common factors of 1/2 and 25 on n squared, what are all of my terms? Well, all of my terms, this one here, right, to get this from, like what do I need to multiply this by to get that? Just the number 1. What do I need to multiply this by to get that? Well, the only thing left over is the 2 squared. What about this? The only thing left over is the 3 squared. There's another one here that'll have a 4 squared. Dot, dot, dot. And the last one, the very last one, an n minus 1 squared. All right, so pretty amazing. This is good news for us because this is a sum of squares. And we're told that we've got a formula here for a sum of squares. Now we need to be a little bit careful because that formula doesn't quite match what we have here. Because our formula is 1 plus 2 squared plus 3 squared plus 4 squared plus n minus 1 squared. Their formula is 1 plus 2 squared plus 3 squared plus 4 squared plus n minus 1 squared plus n squared. Their formula has an extra n plus 1, an extra n squared on the end, right? So I guess what I could do right up here with their formula is rearrange their formula to move that n squared to the other side. So if I just went like minus n squared there and crossed out this n squared here, bye-bye, I now have a formula that perfectly matches this formula. So now I can just like write that formula in place of all of this. All right, so we're really getting somewhere here. We're saying m is equal to 25 on 2n squared and then times all that. But much earlier, we also said that m was equal to 67n minus 160 on 16. So that means that is equal to that. So we have that's amazing. Because what we have now is a full equation in terms of n. 67n minus 100 on 16 equals 25 on 2n squared, bracket n plus 1, 2n plus 1 on 6 minus n squared. Now, I've gotten rid of all of that because obviously this is going to take a little bit of work. So here's a couple of lines of working. So what have I done? I've just expanded this bracket to get this thing here. That's line 1. Now, the next line here, what I've done is multiply both sides by 16 at the same time dividing by, because when I multiply by 16, 25 times 16 ends up being quite big, but I'm dividing by 2, so I only have to multiply by 8. 25 times 8 is 200. And then 200 divided by 6 is the same as 100 over 3. So a lot of stuff is happening here with these 4 numbers. Okay, and then I'm left with this 2n minus 3 plus 1 on n. Now, where does this come from? Where did the n cubed and the n squared and the n go? We have an n squared out here. So when we multiply all of these by n squared, we get 2n minus 3 plus 1 on n. All right, I'm going to expand that. Now, expanding that feels good because I've got this negative 100 and this negative 100 here. I might take this one to this side because there's an n on the bottom. So negative 100 on 3n, leaving me 200n on 3 on the top here. And if I take this over, negative, and I'm going to want to add them together, right? So I want it to be over 3. So 67 times 3, that's like 201. Okay. That looks good because 200n minus 201n is negative n over 3. And I have here negative 100 over 3n. Multiplying both sides by 3 would just kill the 3's. And multiplying both sides by n would give me negative 100 negative n squared. 100 equals n squared equals 100, n equals plus or minus 10, but we're talking about a number of strips. Reject the negative, 10 strips. All right, bonkers question. Like I said, there are multiple ways to solve this, especially when it comes to all this algebraic stuff. There are more efficient ways to do it, but this is how I've done it here. Fun question, celebrate. So that's been part 7 of Guessing the Methods exam. Thanks for coming along. Thanks to my friends, as always, fantastic work. Go and check them out. Last video coming soon.